Good afternoon, my YouTube viewers. Crystal here. I wanted to make you another video, and this video is a solution to Driven Data's swine flu competition problem. So if you go onto the Driven Data website, they have competitions that you can enter, and they have a competition about the H1N1 and the seasonal flu vaccines, and you're supposed to predict the probabilities on both of these vaccines. So first thing I'm going to do is I'm going to read to you the problem statement, which is your goal is to predict how likely individuals are to receive their H1N1 and seasonal flu vaccines. Specifically, you'll be predicting two probabilities, one for H1N1 vaccine and one for seasonal vaccine. Each row in the data set represents one person who responded to the National 2009 H1N1 flu survey. So now you've got your problem statement. So what this is this is a multi-label classification problem. So you are predicting on the probability of multi-label classification. So the first thing we have to do is we have to import our libraries. So I've imported some standard libraries that need to be used in order to use the program. So NumPy and Pandas are standard libraries that you always would use. Matplotlib is a plotting library, and Seaborn is a plotting library too. And then the next thing we do is we import our data sets. We import the train file, the test file, the sample submission file, and the label file. And we read these. So you've got your train file that we've read in. So your train file has, amazingly, you're going to find out the train file has 26,707 rows and 36 columns. The test file has 26,708 rows and 36 columns. So the test file has actually one more row of data than the train file. And then we have the labels. So your labels are the respondent ID, the H1N1 vaccine, and the seasonal vaccine. And these are binary. This is binary data. And then we have the sample submission. So this is what Driven Data wants to see when you submit your predictions of probabilities to them. So the first thing that you're going to have to do is you're going to have to merge your labels to your train file. That will be the first thing you do. And then the next thing you have to do is you have to check to see if there are any null characters in the train file and the test file. And you can see there's quite a few null characters. So what we do is with the entire data frame, we're going to replace all the null characters with mode, and mode is the most frequently used character, and we do that for the train file and the test file. We check to see if there are any null characters again, and no, there are not any null characters. Then what we do is we label and code all of the columns that are objects. And when we label and code these, they are turned to numeric value, which is what the computer wants to see to perform its calculations. So after we've labeled and coded it, you can see that there's no more objects. It's all numeric. And then what we do is we do a plot on the H1N1 vaccine, and you can see that this is class imbalanced. You have more people didn't get the vaccine than did. And then you have the seasonal flu vaccine. We plotted that, and that's a little bit more equally balanced than the H1N1. So now what we want to do is we want to count to see who got the vaccines and who didn't. So the first thing we do is we count the H1N1 vaccine. So you can see 21,033 didn't get the vaccine, but 5,674 did. And then for the seasonal vaccine, 14,272 didn't get the vaccine, and 12,435 did. Now what we're going to do is we're going to go to the process of assigning our X and Y values. But what we wanted to do is we wanted to set up the target. So we set up the target is going to be the H1N1 vaccine and the seasonal vaccine. And then what we do is we plot this on a graph so we see who got the H1N1 vaccine and who got the seasonal vaccine. And now what we do is we want to define our X, Y, and X test values. So Y equals train target, X equals train drop, respondent ID, H1N1 vaccine, seasonal vaccine, and axis equals 1. X test equals test drop, respondent ID, axis equals 1. Because remember, the test file didn't have H1N1 vaccine and seasonal vaccine. And we also wanted to see the shape of these new files, so you can look and see the shape of these new files. Then the next thing we do is we use train test split to split the train data set up into training and validation. So X train X val, Y train Y val equals train test split, X, Y, random state equals 0, test size equals 0.1, stratify equals yes, shuffle equals true. And basically what you want to do is you want to shuffle the training set to make it that the validation set has an equal distribution of class imbalance as the training set. And then stratify turns yes. It helps with that shuffling process and helps with the cross-validation process. So you have to have stratify is yes and shuffle equals true. We want to see the shape of these files that we've created, and you can see the shape. And now what we're going to do is we're going to put our files on the min-max scaler. I use the min-max scaler because your target is binary, and the min-max scaler has a default of 0 to 1. So all of the values, when you use the min-max scaler, all of the values are going to be between 0 and 1. Which should help the computer be able to do its work and carry out the predictions better. So we fit the X train file into the min-max scaler, and then we transform the X train, we transform the X val, and then we transform the X test. And now what we do is we do another disk plot of the Y val H1N1 vaccine, which is the same layout, shall we say, as the training file. And we do another plot of the Y val seasonal vaccine, which is the same layout as the train file. Now what we have to do is we have to define our model. And in this instance, I selected an MLPClassifier. And the reason why is because I used it another time in a multi-class output and it worked. So I decided, well, I don't want to tempt fate, so I used it again. So model equals MLPClassifier, and models equals multi-output classifier with the model. So we fit the model, and then we printed it up, and we had an accuracy on the X train of 72.99%. And then what we did was we predicted on the X val, which is the validation set, and we've got accuracy of 65.48% on the validation set. The next thing that we did was we just put it on my metrics just to look at the metrics to see how this model fared, what they fared with the other scores, so you can look at the my metrics and compare those against the other scores. And then we tested the ROC-AUC score, which was a 72.12% or 13%, and the ROC-AUC score is the score that Driven Data used to calculate the accuracy of the submissions. And then what I did was I made a data frame of the outputs from YVAL H1N1 vaccine and YVAL seasonal vaccine, and then we compared that against YPRED H1N1 and YPRED seasonal, and you can see the coding of how I did that. We created a confusion matrix so you can see how the accuracy rate compared. And if you're good on confusion matrix and you want to check that, you can check it out. We had an accuracy of 65.48%. And the next thing we did was we did just a confusion matrix just on the multi-label. And so you can see the confusion matrix just on the multi-label. So if you're good with confusion matrices, this is a good thing for you to be able to analyze. I mean, I generally just work with accuracy, but when you're dealing with a class imbalance, you have to use a confusion matrix, and you have to count the outputs, resulting output, to make sure that each class is represented in your output. But since Driven Data wanted to see ROC, I believe it was ROC-AUC, I included the ROC-AUC in my program as well, because that's what Driven Data, that's the scoring mechanism that Driven Data is using. So I wanted to see what the ROC-AUC was so I can see what the score is going to be close to. Now what we've done is we make our predictions on X test, and you can see that we have a 2-column array for the predictions. One column is for the H1N1 vaccine, and then the second column is for the seasonal flu vaccine. And then what we do is now we predict on our probabilities, and we're using the predict propa. And then what we had to do was we had to take this propa and we had to convert it into an array as array proba. And then what it does is it converted it into a 3-dimensional array. But it's very difficult for me to work with a 3-dimensional array because I'm accustomed to working with 2-dimensional arrays. And the only way that you can get this to work is to take it down from the 3-dimensional array to a 2-dimensional array. So in order to take it down from a 3-dimensional array to a 2-dimensional array, you have to do proba 0, colon. And what that's going to do is that's going to take away one of the dimensions. And then if you did a shape, then the shape would be 2, and then it would be the number of rows, which is, I think it's like 2, let me see how many rows, 2, 6, 7, 08, and then it would be 2 again to indicate 2 columns. And I'm not sure exactly what the first 2 is 4, but in order to work with this data, you have to get away from this first dimension. And since I'm not an expert, I'm just a novice, I can't really tell you what that dimension is, but it is a 3-dimensional figure, and we have to convert it into a 2-dimensional figure. We have to take out one of the dimensions, and we do that by going proba 0, colon, and that takes out one of the dimensions. And you can see right here, proba's got 2 of these little brackets indicating it's 3 dimensions. And then when we use this formula proba 0, colon, it takes out one of the brackets, which indicates that it's taking out one of the dimensions, which is what we want to do. And then so after we've taken out one of the dimensions, then it's still got 4 columns in it, but 4 columns of information in it, but we only want to use 1 column. So proba 0, colon, that's your H1N1. And then proba 1, colon is your seasonal flu. But what we want to do is we want to check the probability that people will get the vaccine. So since we're checking the probability that people will get the vaccine, it's proba 0, colon, 1 for the H1N1 vaccine, and proba 1, colon, 1 for the seasonal vaccine. And it's very tricky. I kind of had to figure out how to do this myself by looking at the Stack Overflow and figuring it out myself. And then what I've done after I've extracted the probabilities from this 3-dimensional array, which I only use the 2 dimensions, I created a data frame for simplicity. And when I created this data frame for simplicity, I set the column headers as H1N1 vaccine and seasonal vaccine. And then after I've created the data frame for simplicity, I created a second data frame, which is going to be submitted to Driven Data. And so your 3 columns are going to be respondent ID, which comes from test respondent ID, H1N1 vaccine, which comes from DF vaccine, H1N1 vaccine, and seasonal vaccine, which comes from DF vaccine, seasonal vaccine. And so this is the data frame that's been submitted. And then what we do is we take this data frame and we convert it into a CSV file. And after we've converted the data frame into a CSV file, we can download that onto our downloads in our computer, and then we can go onto the Driven Data site and we can submit it. And I can tell you that when I submitted it, what I got was, I believe it was a 60% accuracy or a 69% accuracy. I'll have to look and see what my accuracy was. If you bear with me just a second, I'll just look and see what my accuracy was. I know that you can't see it because the screen recorder that I have only allows me to show just the one screen. But I got an accuracy of 69.20% on the AUROC evaluation metric with Driven Data. And there's a good possibility that I could have improved this accuracy by using a different model, or even, shall we say, I'm just trying to go up in here. shall we say, increasing the max iterations. I could have improved it by fine-tuning MLPClassifier more or using a different model. But with driven data, I'm only allowed 3 submissions a day. And because I'm only allowed 3 submissions a day, I thought, okay, well, I'm just going to stick with this because I know that I'm not a good enough programmer to actually win a competition. I do actually do my programs in a very methodical way, but I'm not good enough to win a competition. So I can put my programs on the solution checker to check my score, but I don't score high enough to get into the top 1%. So it's not really worth it for like me personally to formally enter the competition by submitting my code along with the competition because my score isn't high enough. Although it's pretty high, it's pretty good. So yeah, I'm just going to leave my output as it is and work on other things, because that's the problem with driven data. You're only allowed 3 submissions a day, and since you're only allowed 3 submissions a day, I just have to let it stay as it is. And then if I wanted to work on it some more, then I would have to wait until tomorrow to work on it to try to improve my score. But tomorrow I'm going to be working on something else. So that concludes my presentation for today. This program is on my GitHub account. If you want to go into my GitHub account, you can actually get the files, load up the files, and run the program yourself based upon the program that I have written, because my GitHub account is open to the public. So that concludes this presentation. If you like my videos, please like, subscribe, and share. If you like the work I'm doing and you want to make a donation, then I've got my email address for my PayPal account down below. I don't have enough subscribers to monetize my channel, which is why I have to ask for donations. So thank you so much for watching this video, and I look forward to making the next video for you.